Hope you guys are ready for more sessions of the day. And now we have Anton. He's a senior data scientist at RAMP, working with the data team to turn expense management into a smooth and seamless experience. And in his spare time, he likes to travel, bike around Calgary, and he has two sighthounds he likes to hang out with. And he also likes to challenge himself by assembling complicated Legos. So yeah, I'll give the platform to Anton and let him take it away.
Hi everyone. Do I even need a mic? Don't know if I need a mic. Is this all good? All right. So yeah, my name is Anton. Today I'd like to talk about setting up really powerful data validation and data quality tests using this great open source tool called Great Expectations. Just to set the expectations, so to speak, this will be a technical talk with a few cheap tricks to make it look like it's a bit less technical. So let's kind of start with stating the problem. Unfortunately, the problem is actually pretty huge. Data validation actually doesn't have any strict definition, and it's super loosely defined, and as a result, it depends on who you ask in the data team what data validation really is. Kind of like pineapples on a pizza that separates the people into two camps. By the way, why is data validation really important? Well, because if you plug invalidated data into whatever project, pipeline or black box you're using this data, you will get garbage results. So invalid data produces invalid conclusions. Let's kind of talk over multiple personas in the data team and see what they think about data validation. So let's start with the data engineer point of view. To them, validation is often about how the data is stored. Correct schema is obviously important, as well as tracking that schema changes and making sure perhaps that the schema is optimal. If it's suboptimal, we've got to fix it. How do we fix it? Through proper data modeling. Proper data modeling hopefully leads to lower cloud bill. So in the end, to a data engineer, valid data is something that is stored properly and is synced properly, as often as the business requires. From a research data scientist perspective, which I hope there are some folks in the audience that are research data scientists, like the POC champions. From that perspective, the valid data requirements are heavily domain-oriented. So our inputs and outputs need to make sense from the physical point of view, or from, I guess, the domain point of view. So for example, if we're working on a model that uses people's height, that height should be constrained within reasonable bounds. 272 apparently is a world record as of today. Not sure about 30. If we're using weather data, we should make sure that the snow amount of June actually does not exceed snow amount in January typically. More often than not, we often like that basically what we train on is similar to what is in the holdout, that what is we test on. And finally, your favorite data is also valid when random forest trains on it. So that's kind of where the research data scientist typical perspective ends. For an ML engineer in the room, don't know how many there are here, we usually expand on the requirements that a data scientist has. And we would like to make sure that the new data is, again, similar to trained data. And by new data, I mean something that goes through the production system, not a holdout test that a research data scientist used. We want to make sure that the format of that new data is actually compatible with a model that is being, that this data is being passed to. So basically, does the predict call still work? Also, we want to make sure that the distribution doesn't drift. So, for example, if we're dealing with the weather data and just switch from one provider to another, what classically may happen is that your wind speed used to be in kilometers per hour, now it's in miles per hour. wind speed, temperature used to be in Celsius, now it's in Fahrenheit. Those are two dramatically different distributions. Therefore, we should make sure the data quality tests catch that. To many managers of data departments, valid data is something that is relevant to the business and captures its state over time. It is also something that is easily discoverable and can be reliably used in production dashboards. So basically, we want to make sure that we can provide a single source of truth, and that truth is actually truth. An additional requirement from a manager could be that, not that I just want the valid data, I also want this data to be to have some kind of a value for the future work. So basically, we'd like to enable some kind of ML fancy work. So basically, this kind of all good. Basically, this is my quick overview of the 4 typical personas, and clearly they have somewhat different beliefs as to what valid data should look like. Thankfully, Great Expectations covers those use cases altogether and comes with really nice observability and alerting tools attached to it. How do we actually set up validations with Great Expectation? It's much easier to walk you through as to how it works via an example that I'm about to introduce. This is an off-the-shelf data set. You can't see much from the further rows, I believe, but just trust me on this. It comes from UCI repository, and it's a data set of famous historic figures. I didn't make it up. It is a true data set. It describes those people by their name, what they did, gender, country, occupation, birth year, death year, and age at death. Imagine this data set to be repopulated with new data daily, perhaps in batches. Perhaps we're retrieving that from some side source like an API. So again, if we go through the different personas, we can sort of set up some pretty definitive expectations of that data. First of all, an analytics engineer who is going to build dashboards perhaps from this data, they would like to make sure that the name is a constrained length. It's not like a erroneous dump of some PDF field, but rather an actual name. We want to make sure that the IDs in that data are unique, not missing. We want to make sure that the country is a real country, not Stormlands, not Gondor. We want to make sure that the birth and death years also make sense within a reasonable bounds, and that the age of death is calculated as a difference between the two, maybe with some sort of uncertainty, but we don't also want it to be strictly positive. A data scientist who has seen the data before might be a bit more picky. They might want to make sure that the columns in this data are ordered in a specific order that the model, for example, accepts. We also want to make sure that perhaps certain stronger statistical constraints are valid, such as age follows a certain pattern, perhaps the location of people follows a certain distribution pattern, and we want to make sure that if we were to train on this data, we don't have more than 10% of null values per each column. This sounds like a super complicated long list of requirements that would be kind of tedious to express in form of classic SQL tests or classic unit tests or DBT tests, whatever you use. Great Expectations allows us to express all those in all those desires and beyond in form of code and do it interactively while playing with the data. So Great Expectations comes with a CLI interface that allows you to easily start the process by connecting to a database or getting an example data from a flat file, such as CSV. And then you can express your requirements in form of expectations in a Jupyter notebook. So for example, here I added 2 chunks, and I want to make sure that the death year is between 0 and 2022. and the manner of death has values populated 95% of the time, and 5% or less are allowed to be nulls. This is what we call fuzzy data validation. So we basically allow for occasional human error. We can save those expectations into a JSON file, and vice versa. Given a JSON file, I can actually create a Jupyter notebook without writing any single line of code. So it allows me to serialize and go back and forth and fine-tune the expectations. Based off the JSON file that I just talked about, Great Expectations can actually generate user-friendly documentation where it will describe what expectations we have about any specific data source or a file. So you kind of first see how it breaks down things over the table level. So at the top, we see expectations that are applied to the whole table. We want to make sure that the columns are in a specific order as specified there. We want to make sure that there is a certain number of rows within this batch. And then there's a table of contents, which will walk you through expectations on a per column basis. And it will enlist them group per column. You can press on that, and I'll show that how that works interactively later if time allows. You can press on that, it will drop you to the point where the expectations per that columns are specified. So for example, here, the age of death, we want to make sure it's between 0 and 80. The values must not be null, at least 95% or 90% of time. And there's some constraint on the value types that are, I didn't make it, just added it for fun. So we then have a kind of clear, basically clear description what those expectations mean. The best part of it is it's all automatically generated. Again, all I had to do was that Jupyter with a couple chunks and all of this interactive documentation is automatically generated. We don't need to do anything to get that website going, and we can drop it to S3, to whatever your favorite web hosting platform is, and people within your company can actually reach it and explore. Great Expectations also have great documentation on how to set it up with the various data sources. But also they have a gallery where you can explore what sorts of requirements you can get from the data. There's like there's about 358 types of expectations. They're all nicely semantically available, semantically searchable. So you can type in, I want values between X and Y in a column, and something will pop. So it helps you discover new expectations that you didn't know actually existed. So more practical, how would you integrate this thing in your flow? Those of you who are either working for a data platform team or manage a data platform team or about to set up a data platform team, this is your time to listen. So we got to start with an offline work first. This is where your data scientist or subject matter expert are involved the most. So they will typically have to take an example data, and Great Expectations comes with a tool called Profiler that can actually pre-create some of the expectations for you, so you don't even need to invent the wheel. So we'll look at your data and come up with some reasonable suggestions. Based on that, you can fine-tune the expectations and capture the more relevant domain knowledge in more specific expectations. You can then run those expectations on data, see if that test passes or fails. If it fails, how did it fail? Once you're done with fine-tuning, you can generate those data docs that I just walked you through. And so on kind of the right, you can see basically how this whole process flows from the file all the way to the browser where you see the docs. Now we switch to the online part of the Great Expectation usage. So once we set up all the expectations, we can move on to plugging it as part of our data pipeline. So typically, if you, again, are a bank or a company that has lots of relation databases, and then you're building something like a data warehouse, you would probably want data engineer to do most of this work. First thing you'd have to do is to configure create expectations, which is basically filling out a simple YAML file where you describe where the data comes from, where the tests should be stored, who should be notified. You set up all those things. Sounds complicated. It's not. Then you try to find a proper place for the checks, so basically where they should go, and then configure the alerts notification. You can either send an email or send a Slack notification to key stakeholders and perhaps yourself as well, to make sure that if the data fails the validation test, people involved are aware. You can kind of do it in many ways. There's a possibility to do your custom Slack notifications that I set up in my previous job. So basically, in this case, you can see some relevant metadata about a validation run. In this case, we were running a validation before training a model for predicting PV panel power output. We also captured basically the versions for the prediction service that we set up and relevant links to the docs that basically describe how this validation ran, if something failed or not. So everything, as you see, is I guess pretty easy to customize, and it says that it was a success back then. Do I have anything else? Oh yeah, I can now jump into an example. Looks like I have 2 minutes left. Oh wow, I cannot jump to an example because I can't switch the tab. Oh yeah, this is an example. Jesus. Yeah, right there. All right, so super interactive. Expectations for manner of death. Where were they? At the very top. Oh, maybe not. Death year, right there. So now you can see what was the expectation for the death year. So this is what is called, I guess, expectations docs. And then we can also go and see docs for each run. So this run was a local run on this data. Looks like it failed. Why? Because we ran 25 tests, 20 of them succeeded, but 5 failed. And we don't allow any single test to fail in this case. We could, but in this case we didn't. And I can see what exactly failed. So it looks like the table expectations ran just fine, but surprisingly, we don't have unique values in the AD. Boom, we caught that before this data went into something more important. We also probably have some other fails. Ooh, boom, birth year was negative. Whoa, what kind of models are we going to train on negative birth years? So this is basically a way to explore the data. Now, hopefully I can get back to the presentation. Oh, boom. Same thing in static form, basically what I just explained. We can see the example values if the expectation fails. And I think that brings me to the end of my presentation. If I was not persuasive enough, you can go to that website and read the testimonials from all these highly talented people. Ignore the one from the guy who stole my first name and last name. But the other 2 are, I think, pretty legit. And finally, if you made it to the end of this presentation, I work for a company called Ramp, and we're hiring a lot of people these days. So if you're interested in disrupting the finance and expense management, talk to me after. I'll be happy to chat. Boom, I'm done. Yeah, questions?
Oh, great presentation, by the way. Just a small question. So you said it's open source. Can we access it on GitHub? Or?
Yes.
Okay. And it's just like if I wanted to use it in Python, I can just do pip install?
Pip install, yes.
Okay. Thank you.
All right. You go first. Yeah, you go first.
I just want to ask a question on this slide.
Oh, go ahead.
Okay, so when we do the the validation, do we do it for on a training data set, or we also do it on like when the model is in production, we also do it on the new data comes into the.
Solid question. We do both. Well, I mean, some companies do both. Most companies should do both, in fact. Before the batch comes in for prediction, if let's say it is a batch prediction system, sure. It may not work very well for like super heavily loaded, very frequent batches, but there's ways around that too. But yeah, we would use typically for both cases.
Oh yeah, I'm just thinking about how this tool can be integrated into the pipeline. Yeah. Okay. Thanks.
Yeah. So
oh, sorry.
typically, if it is a data warehouse building, you put it at the end when the warehouse is built, but not promoted, right? So before promotion, you want to make sure that everything's squishy, the dashboards are not going to break. And if that's all good, then you can safely promote. Otherwise, you should probably not promote.
On one of your examples, potentially trivial, can you cascade or stack your expectations? One example being your snow level in June should not exceed January in north of the equator, but it would have to be the inverse if you were south of the equator.
Yes, you can.
So one of the things that we struggle with in our data is basically when we write these rules, we start to get a combinatorial explosion of test cases that we need to write. Some things that we've looked at are like unsupervised ML for monitoring our tables. But I don't know, how does this compare to other data quality tools? Besides being open source, then it's definitely free. But
right.
Data quality tools like say Monte Carlo or
Yeah.
Big Eye or Anomalo.
Yeah. Monte Carlo, okay, first of all, Monte Carlo is similar tool, paid, their main competitor. Great Expectations, though, it does have a hosted cloud, Great Expectations too. So they kind of match that. With respect to combinatorial explosion, that will probably be the case for many automated tests, right? When you try to, like, for this, for that, generate a test. There you go, n squared complexity. Folks at Capital One did a very neat trick with Great Expectation. They actually set up ML models that that check for the types. So for example, if your type is a name, that's difficult to test for the name, right? But if you have a model, such as BERT or something else NLP driven, you can actually use that model to figure out whether the type is a name or not. And that's one of the kind of neat things that were implemented. So they have a very strong custom expectations ability. And we've done before too. We've done that before. Sure.
Thank you for the presentation. I have a question regarding these steps that you mentioned in validation of data. One is maybe missed is how to deal with fairness of data or bias that people they have, the scientists they have as a company. How to deal with the bias and fairness of data in modeling?
Good question. So I guess that the answer is that it depends, right? So if it is something like I can pass a batch of data and I need to evaluate for the fairness, I hope you have a model to do that, or I hope you have some kind of heuristics to evaluate that. If you do, then you really are in kind of the same boat. Just add that check. So you need to be able, I guess you need to first decide how you do that evaluation quantifiably, and if you can quantify that even to like binary yes or no, you can plug it in with no problem. Does that answer? Yeah, you had your hand for a while.
Should I just hold it? So I guess from the standpoint of the workflow, so I saw that if something doesn't meet expectation, you can fail. So I guess, can you, for example, okay, it doesn't meet expectation, but it goes further, but still has a table where it kind of populates all of the, like, what do you do with those who kind of, with the handling the rules? Can you put them back in a data set? Because you cannot amend the source, but maybe you can make changes. And
yeah. So I skipped that. Thank you for that. That was like one of the pieces in the notes. So there might be two suites of expectations. So something that we did in the previous company was we get a data. Some of it are nulls. We fail those expectations because we see perhaps too many nulls. However, we have neat tricks to fill the nulls. So we fail the first set of expectations. We fill the nulls, but who said that your null filling procedure is correct though, right? Could fail too. So then we put another set of expectations that checks whether your null filling process actually didn't make the data worse, perhaps. So that's why some of them might be critical at the very beginning, and some of the expectations might be put at the very end. And if you're a fan of Dagster or Airflow, all those things can be easily orchestrated with what is called a great expectations operator that Astronomer manages,
So basically,
maintains.
it's some kind of iterative approach. So you kind of take first step, check it, do something.
Yeah, you could definitely make it iterative if you wanted to, but typically, yeah, you would set it up preliminary set and then like the final one.
Makes sense.
I arrived a bit late, so apologies if you have already addressed the question. My question is that how is the performance if we have, for example, a 10 gigabyte CSV file and we want to have 20 different things checked against it? Are we talking on a normal laptop? Would it be seconds or minutes or half an hour?
Depends on the set of expectations too, right? So like let's kind of split here a little bit. If it's a normal laptop, great expectations out of the box are parallelized. So you will run your expectations in parallel. If it was a flat file, 10 gigs, I would seriously consider perhaps DuckDB or some other DB for this. It'd be painful. It will run though. In the cloud, again, if you're running through Airflow, that thing, and let's say Airflow is set up on cubes, as you learned from the very first presentation on the first day, it can scale pretty enormously. So won't be really a problem. And like I said, there's multiple backends. You can use your relation database, Databricks, Snowflake, whatever data you want. So yeah, it will chew.
Thank you.
2 more minutes. No, sorry, 1 more minute. Oh, yeah, sure.
Would data sources would also be applicable for like NoSQL data sources, like as in JSON or anything like that?
Bingo, good question. So it does generalize very well. So it has this concept of data sources and data like engine. So what you would want in this case is perhaps if your data source is not available readily, you would want to use the general Pandas or Spark engine, and you won't even feel the difference. You actually don't need to change the code at all, right? That's the beauty of the great expectations. Once it's in a JSON, it will run equally well on any of the data sources. So if it's something comes from API or from NoSQL database, it will work just fine. And there was a question over there.
Yeah, I'm kind of wondering if you can talk about sort of the business context and what impact this tool's had. So obviously I'm seeing data quality is an impact here. Are you finding that you're able to get your ML models to production quicker? Are you able to make better decisions? Like what has this tool meant for your business in terms of benefit?
All right, I'm not, I guess, speaking on behalf of my business, so I'll talk about previous cases, so that's all right. It's twofold. A, training the model on the right data was of utmost importance to us because we were making real decisions that were moving energy from one place to another on those outputs. So we wanted to make sure that we train on the valid data. Two, whenever we show customer whatever dashboards, plots, we are not gonna be happy if they are not happy either, right? So if they send us a complaint saying, why is this showing empty battery whereas my battery is clearly full, that means something went wrong with respect to us testing the data before promoting it to the visualization layer, to like the expert layer. So yeah, it's, I guess, pretty important.
So great expectations is a Python framework, right?
It is a Python framework, yes.
So when you run it, for example, on Spark, will it run in parallel or?
It should, yeah. this is going into details, 15 seconds on this, and then I go. They actually, behind the scenes, for every that dataset engine, they rewrite the expectations in the language of that engine. So for Spark, obviously the code is going to be different than from Pandas. For SQL, you're not going to materialize the whole table in the memory, right? So for SQL, it will be more like a programmatized SQL statement. So it's pretty neat that way. We're good, right? I'm done.